So we're going to use this data. So this data comes from the universal bank data set, but we're going to look at only one predictor, and that is income. So income is in $1,000, and personal loan offer, whether the customer will accept a personal loan offer or not, that's our target. So it's either 1 or 0. Okay. So now we're going to have to set up a L function, okay, and L is like that. That's our model, beta 0 plus beta 1 x, and we want to figure out estimate for beta 0 and beta 1, and those estimates are going to be in these two cells, right? So we can set up a equation for L for each row. So that will be beta 0, that will come from that cell, right? We don't know what value there is, but solver will figure that out. We want to set up the model right now. So we have to make that absolute reference plus, right, P sub 1, again that should be absolute reference, times the income. So now here our L is B sub 0 plus B sub 1 income. So that's our L. Okay. Okay, so right now both cells are empty, so L is 0, right? Now let's copy that all the way through. Then we can go straight from here to there, but let's do it step by step so we will know, we won't make any mistakes. So the first thing to do is to convert this L into e to the power of minus L. Okay. Now when we do 1 over 1 plus this, that will give us our P sub y, or y hat. Okay. So that's our E, so that part. Okay. Now the probability, okay, is, so that's our y hat, and that is 1 over 1 plus that. Okay. So let's go ahead and copy that. So now we'll set up the likelihood function for each row. So that would be P sub y to the power of y. So y is that. Okay. Times 1 minus P sub y to the power of 1 minus 1. Remember, this function will give us the probability of whatever value we have here. If this has 0, then this function will give us probability of y equal to 0. Okay. And if column M has a value of 1, then this function will reduce to probability of y. Okay, so that's how we have set up the function. So now copy that, and then finally we do a natural logarithm of that. Now the sum of this is our, so that's our logit function. So we need, that's our likelihood function. Logit function is this. Okay, sum of that. So our problem now is to figure out values for b sub 0 and b sub 1 such that this function is maximized. So that's our maximum likelihood estimate. That's why this is called maximum likelihood estimate. So maximizing a function with constraints is, in Excel we use what? Solver, exactly. So we go to solver. Okay. If you don't see solver, what should you do? You have to add, exactly. Yeah, so you do options, file options, and go to add-ins and Excel add-ins, and then make sure that solver add-in is checked. So that will add our solver for us. Okay, so now we want set objective function. So that's the objective function that we want to maximize. Okay, and then changing cells are these two. Okay, now we need to make sure that this is unchecked because there are no constraints for b sub 0 and b sub 1. So if you have this checked, then that means b sub 0 and b sub 1 is now constrained to be a non-negative value. But we should allow b sub 0 and b sub 1 to take negative values, and therefore that should be unchecked. And because this function uses logarithm, natural logarithm, you have to use non-linear method, GRG non-linear. Okay. So that's it. Now you click solve. So that gives us an estimate that maximizes the value of this likelihood function. Okay, so our logit function is b sub 0, so that is minus 6.1268, right, plus 0.03712 income. So that is our logit function.